What's good, everyone? This is Mr. Ben coming to you from Washington, D.C. We're about to jump into some 8th grade math. Let's do it. All right, so this is Module 1. I'm seeing that my face is covering this, so let me move my face to right here, and I'll play around with where to put it. Okay, this is Module 1, Lesson 1, very first lesson, exponential notation. Let's jump into what exponential notation even means. You'll see the captions on the bottom. You can pause at any time to make sure you are catching what we're saying. All right, that icon in the top left, these building blocks, that essentially just means that this is like a recap, something to build from. All right, so take a look at this first problem. This is something that I bet most people can just kind of do in their head. You can either add 5 plus 5 plus 5 plus 5. You probably know this. You can do 5 times 4. That's because repeated addition, when you repeat addition, you're really just multiplying. 5 times 4, okay, we know it's 20. Keep that idea as like a building block to the next thing we're going to learn. This light bulb in the top left, that kind of means that we're going to move to a new idea. All right, let's jump into it. Same problem as before, except what do you notice? That's right, now we're multiplying. You could on the side do 5 times 5. All right, you can do that in your head. All right, 25 times this 5. I know that. I don't know if you know it in your head. That's 125. And you can do times this final 5. 125 times 5. Again, I don't know if you can do that in your head. I can barely do it in my head. I think I've just seen it so many times. Pretty sure it's 625. Now, this is something that gets more and more difficult to do once the numbers get larger. What if it was 9 times 9 times 9 times 9? Or 21 times 21 times 21 times 21? We want a simpler way to write that out, and then honestly, a simpler way to input that in our calculator. You don't want to be sitting there on your calculator going 5 times 5 times 5 times 5. You want a quick and easy way to do that. We use exponential notation to represent this idea of repeated multiplication. So the number 5 is what we call our base, and it occurs 4 times. So that's our exponent. Base and exponent. This little running man icon in the top left just means that we're going to do some quick practice. All right, so for example, if you saw a problem that had 4 times 4 times 4, to write that in exponential notation, 4 is our base to the 3rd power because it occurs 3 times. 21 times 21, 21 is our base to the 2nd power because it occurs 2 times. -3 times -3 times -3 times -3. You see it starts to take a while to write it all down. That's kind of the value of exponential notation, and I don't have to write this out every time. -3 is our base. Keep it in parentheses, and it occurs 4 times. Keep in mind that we can also start with exponential notation, and now we understand what it means. 6 times 6 times 6 is really 6 to the 3rd power. -2 to the 2nd power. Well, that's -2 times -2. Putting in parentheses helps us make sure we understand what we're multiplying. One more to go. You can even do this with decimals. 4.2 to the 7th power. 4.2 times 4.2 times 4.2. You kind of get that this is getting repetitive. Again, this is the value of exponential notation, that you don't have to write this out in what we call standard form all the time. Oh my gosh, how many more do I have to go? 1, 2, 3, 4, 5, 6, 7. That handwriting is garbage. Oh my Lord. Sorry about that handwriting. Again, exponential notation, we use a base, 4.2. We use an exponent. In this case, it was a 7. So much easier to write out than writing 4.2 times 4.2 7 times. All right, let's examine something and with a little more specificity. So you see that that magnifying glass with the gears? That's just an icon that means we're going to look at something carefully just to make sure we understand it. If you have something like 6 to the second power, you know that's 6 times 6. 6 is the base, 2 is the exponent. 6 times 6 is 36. If you have negative 6 in parentheses to the second power, that's negative 6 times negative 6. Negative times a negative is a positive. Our answer is still 36. If you have negative 6 to the second power with no parentheses, this is where we really want to examine this. We're really doing 6 times 6, and then that negative is dropping down and being tacked on to the end. So this creates a situation, this last one here, where our answer is actually negative 36. This is all just to say that you have to be really careful that if you want your base to be negative, remember the base is this larger number here. If you want that base to be negative, put it in parentheses. Make it obvious and very clear that that's what we're looking at. Okay, this little red face in the top left icon just means that's our last slide. And I'll leave you with one thing to think about. All right, here's what I want you to think about. I'm interested to hear what you think about this. We just did something like 4 squared. Exponential notation really means 4 times 4. Happens twice. 16. Cool. But what if the exponent was negative? Again, the exponent now is negative. What happens to our answer? How do you solve a problem like that? Think about it. I'm excited to hear what you think. This was the end of our lesson on exponential notation. You learned about what it is and how to think of it as repeated multiplication. Thank you for joining me. Goodbye.